Hey everybody, me Keith, Elder Rock, back on the bench with our next video. Not sure if this is going to be a how-to video or just a general follow along on another RGB mod. So we just finished up the Hitachi, and that went pretty well, mostly. No schematics. It didn't work when I got it. It was a bit of a learning experience. But this one, I think is going to be a little bit better. So anyway, I picked up a Sony Trinitron G14B1. And this is a, here in Thailand, it's, I think, dual voltage, 110, 240, 50 hertz, 60 hertz, gal, pal, monitor, TV. So I picked this one up and I thought it had composite, but it does not have composite. It only has RF. And I'm willing to give it a shot anyway. So we have to research on how to RGB and RF only monitor. But after coming off the win on that one, I think I have a pretty good idea. But this is today's only video. I just popped it apart and it's filthy. So, okay, just a little interruption there. So anyway, this is my only video tonight because as you can see, this thing is just filthy. The other one was pretty clean, but this guy, not so clean. So there's the model number. And so we have an RF input, and I did wipe off the microprocessor. So hey, the good news, kind of now that I kind of know about these, I spent such a long time learning about these, studying, looking at this processor. It is a Sony TDA 8374. It's an I2C bus controlled economy PAL NTSC TV processor. So just kind of looking at, it's basically the jungle chip. It don't have a microprocessor, I think, in this. It may, I could be corrected, underneath that metal case there could be a microprocessor. I do see like some chips up in there, but kind of reading the data sheet. So we got the data sheet pulled up. And I think we're going to be able to mod this thing. It's got everything we need. I'll just go to my notes for now. I think it has everything we need. It has a composite Y input. It actually has three inputs. Has a composite external input, and there's another internal input. It has red, green, and blue inputs, and this insertion point, I believe that's the blanking. And I was making the notes, I was reading the data sheet, and it got down to a point where it said that the insertion point is indeed the blanking. So it's got our blanking pin. The OSD might be tied to the outputs, but I think we can switch those. And yeah, we'll see what we can do if we get an RGB guy on this thing. We'll go into schematics later. I'll throw them up below, or as I'm making some video, I might try to film a little bit more of this. But I'm done for the day, and tomorrow morning I'm just gonna take this thing out in front of the apartment. They got a hose, and I'm just gonna hose and scrub this thing down. And that's the great thing about Thailand. It's so hot here. It's like a bake out oven outside. So I can wash this thing. Let's let it bake out and thoroughly dry. Then we'll get this guy apart. I've already not degoused it. I've already discharged it. So probably just take this thing apart, get it out, get it clean, get it back on the bench, and we'll start looking at the jungle chip, that NTSC PAL controller, and see what's I'm guessing I'm going to find inputs that are not used, and I can pretty much find where the tuner is going in. I'm guessing, we'll see. I'm not gonna make any guesses. I think the tuner is probably going in one of the composite inputs, but we will find out. And the TV works. I should have showed that before I tore it apart, but I've had it plugged in, both the 220 and on my isolation 120 volt transformer I had for the Japanese TV over there, so we can work on it safely. But I still want to measure some resistances on this chassis just to make sure there's nothing weird with it being a hot chassis or whatever, even isolated. So it pretty much has to do with, you know, your high voltage part to your grounds. We'll check everything because it's still kind of new to me, and I don't want to die enjoying my hobby. So, okay, guys, see you in a few, maybe in a day or two. Get this thing cleaned and dried. Okay, so hey, we're back with this Sony 14-inch Trinitron that I made a quick video. I opened it up, it was filthy, so I didn't even wash it. I just brushed it with a paintbrush. I took it outside. Look how nice and clean that chassis cleaned up. And check out the tube. The neck board, the whole case. I did wash some of this, but it looks great. And also inside the back, the rear cover, super clean. That's how I like to begin a project, with clean equipment, because it's really just about restoration, right? That's what we do at Arcade Laboratories. I save the old PCB games, power supplies, and whatever comes across our bench. So yeah, I'm still setting on my bench, and hopefully use one of these for my test bench. But here's the Hitachi we just finished up. That thing is good to go, and I learned a lot from that. RGB mod number 1. So this is RGB mod number 2. Let's keep it rolling. Okay, so we have the Sony G14B1, and I bought this thing. I mentioned it in my first video, but this thing is a RF only. See this whole big unpopulated section? This is where your external video and audio jacks would be if it was a different model. But it's all unpopulated, and it's actually going to work out in our behalf. So I was doing some research. I'm going to take you to the computer and show you what I found. And I mean, in this video, I am going to walk you through. We're going to solder, desolder. We're going to test everything. But I'm going to kind of show you some of the material I found, and I'll put it in the link below. And if you guys ever have come across the Sony BG1S chassis, that is the chassis designation, and they used that all the way up to I think 31-inch TVs. Okay, so a guy on GitHub, this is a GitHub thread, I'm just going to say pre-Derek, put together a really nice document, and this is a really great guide, step by step. I'm not going to go through this whole thing, but I want to go through. I'm going to go through some points here before we jump over to the schematics and then onto the board. He has a parts list together. One thing to note: these 75 ohm resistors. There is a video out, it's actually at the bottom of this link, where a guy, a really nice guy, I love his video, I love him. Who is he again? I can't remember his name. Awesome guy. He went with the 75 ohm termination, and he even says in his video that the picture is a little bit dim. And after my friend Steve helped me with the Hitachi, I'm going to adjust these 75 ohm resistors to get a more bright, vibrant color. But I did get some 75 ohm resistors to start with, but we'll probably dial that in later. I'm just going through his steps. I mean, they would probably be like my steps. Dismantling the TV. Be careful. Discharge your tube and don't hurt yourself. don't hurt yourself. Go to and research how to discharge the tube and how to be safe. I'm not going to be one of those guys. I'm not going to be responsible for what you do. What you do at home is your own thing. If you dismantle it, go down a component level, just know that there's safety precautions that you need to take, and discharging your tube is the number one thing. Okay, anyway, let's go back up on here. I'm going to talk about this section right here, kind of what I was talking about before. On the board, on this schematic, and I'll show you on the schematic right now. I will show you on the schematic right now that the jungle chip, red, green, and blue are not, they're not connected and they're taken to ground. Well, mine is on, oh no, where is it? Oh, right here. And then on, oops. Yeah, this is the jungle chip. Let's go to the red, green, and blue. Your red, green, and blue, they're gonna be terminated to ground with these resistor. So the one on this board, they're actually 0 ohm. So my red, blue, and green are tied straight to ground. On the other videos that have the composite input, these are like 150 ohm. So that's where you got to be diligent with your resistor values and kind of know what model that you're dealing with. Okay, so let's let me zoom back out and we'll jump back over to this. Okay, so that's what he's talking about on this step. So so let's just say we had resistors there. We have 0 ohm resistors there. So I'm going to pull those out, and I'm going to actually put my resistors up on the part side of the board so I can dial in and play with the termination resistance and hopefully get a better picture. Good thing to know on this chassis that the red, green, and blue blank and ground are they are available through a connector that's not used. So I think it's the 106 connector. Let's see, blanking, the 106, and I'm going to show you on the schematic. I'm going to show you back on this. Go back down here to the schematic, go down one page, scroll over to the edge. Oh, up, I mean, gotta go up. Okay, it's going to be the CN connector 106 that is not populated on the board. We're gonna use that for our RGB injection. Like I said, mine are 0 ohm to ground. So right now, my RGB and blue are all grounded. They are all grounded. They beep out, beep, 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 and they all beep to ground. So here in a second, we're going to go ahead and pull those. We're going to pull those resistors together, and I think that's all the main points I wanted to hit with you. And he did a wonderful job on his site. Pictures. He has pictures. We're going to grab 5 volts from the same place, and we have to build a voltage divider because that's 5 volts. And on the jungle chip blanking, you're like allowed a maximum of 3 volts. So, but I think one thing I'm going to do, not in this video, but I'm going to get set up to do some testing. I'm going to show you later on in this video. Let me go to the data sheet. Okay, so this is the data sheet, and we have the TDA 8374. It's an I2C bus controlled PAL NTSC TV processor, and that's actually the other cool thing about this TV. It's dual voltage. It can be NTSC or PAL, and it should be automatic. So we're gonna go down. Let's see. I'm sorry I didn't have this more ready. the demodulator. We're going to look at some of the voltage settings and the amplitude. And when we go, we're going to set up a little lab experiment. Not experiment, we're just going to do some testing lab style when we get this thing kind of hooked up. I got a breadboard. Okay, here we go. No, that's output, RGB outputs. But we're going to be looking at stuff like this. This is what I want to kind of show you in my video. RGB outputs, your minimum, maximum, optimum voltages. And if you've never done an RGB mod before, those voltages are really important for your picture brightness. You want to have that pretty well dialed in. Reference single, let's see. I know there's what did I lose? Oscillator. I should have had this on the right page for you guys. But all of this is really good information. If you go doing an RGB mod, especially if it's one of your first ones, definitely pull this up. Okay, so I think we're getting there. Okay, sync video input. So we have pretty much 3 unused inputs on pin 11, 13, and 17. So they're pretty much composite inputs, but they tell you for optimized performance of your chip, your low value, your high value in your unit in millivolts, and optimum being 300 millivolts. So before we hook anything up and inject anything, we're going to make sure that our voltages are kind of where we want them to be safe. If you pumped in too high of a voltage or amplitude, you could cause damage to that chip. I think that's kind of what happened to the Hitachi over there. This OS color differences. It gives you your blanking signal, your blank signal, input voltage, no data inserted, so pretty much very low, 0.3 volts, kind of pulled low. And for your blanking maximum input pulse, I'm just calling it high or low, maximum of 3 volts. So I think we're going to grab like a 5 volt line and we're going to cut that in half, and our blank will be at 2.5 volts, which is within that safe threshold. Oh, good Lord, there it is. Okay, RGB inputs. So here later, after we get our cabled up, get our wires, we're gonna break these out on the breakout board and look at these. Voltage for your RGB, optimum 700 millivolts, maximum 800 millivolts, and that's not that high. And that when we get over to the board, I'll show you something else with the CVBS. I don't know on this data sheet. I think this voltage, it says voltage 11, but I'm pretty sure that applies for 13, 17, and 38 as well. So our composite input, really a maximum of 1.4 volts. And I have my cheat sheet already all done up. And current, I think that's pretty crazy. 4 amps maximum, actually that's on the minimum current. So it could take some pretty good current, but we don't want to overdrive that. And I think with that being said, we're going to get more into that when we get the breakout board going. So I think that's all I really wanted to cover up front about the material. Definitely, if you do an RGB mod, pull up, do your research. You're going to save yourself a lot of time. I mean, you might have a TV that you can't even RGB mod, but do your research, look at the data sheet, try to understand the data sheet, the acronyms, your voltage limits, and you'll come out, your end result will be much better if you put the time into it, and you won't be fighting yourself. And with these chassis on the surface mount, they're so small, you don't want to be doing a lot of rework, and you don't want to do sloppy work and short things out. So that's it for now. So let's go back over to the to the chassis. We're going to flip it over, and I'm going to walk you through some of the stuff here that I already found. Yeah, I got my blocks back out because I don't want to damage my flyback or anything like that. Okay, so this is our jumbo chip here, and what we're gonna do, the jungle chip, yeah, this is your 20, let's see, 29, oh, it's on this side. Let's see, 28, 27, 26, blanking, RGB, all of these, ding, 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 they make their way down, and this is the backside. This is the backside of that CN106. And these three resistors here, 0 ohm resistors, are tying all of these to ground. So right now, if we buzz those, yeah, it's really kind of great. Everything is available. Everything is available. If we go RGB, everything shorted. These are 0 ohm resistors. These are all taken to ground. So regardless, those got to come out for our termination. We could probably leave those in, add our resistor and termination, but I'm not gonna do that. So let's go ahead. I got the solder gun fired up here, and let me slip over here and grab my tweezers, and I think I am gonna I might have to add a little bit of solder. So I'm sorry, I gotta pull that down. Can you zoom in right here while we do this? So that's part of the, you know, I like to make soldering and desoldering videos. So we're going to desolder our 327, our 328, and our 329. So let's see how bad I can, or good we can do this. Let me get the solder gun, and I did leave my hoofed, I was going to put my fine tip on, but I left my hoofed tip in here because I think I can get these out okay. I think I'm just gonna add a little solder on that guy, and it should pull right off. Ooh. Maybe. Let me get my tweezers. Alright. Ooh, it's so small, you guys. Yep. Boom. And I'll put it right here so you guys can see it. I probably didn't even need to add solder. Okay, so this one's gonna go. Ooh. Ooh, there we goes. Very nice. And this guy's gonna go. Alright, so cool. We just isolated. Oh, not yet, not until we get this one off. When you get that heat build up in there, it should go pretty good. Let me get that guy. Oop. You gotta be careful, you don't want to pull the pads and stuff. There it goes. 3 0 ohm resistors. Okay, I don't know if you can see this right here. Zoom in right here at the end of my tweezers. So this is coming, this is a place for a capacitor, a 0.1 microfarad capacitor for your composite in. It comes between your composite in, if it were populated, and to pin 17 over here, this pin here. So we're gonna, instead of putting a capacitor there, I can't get any surface mount capacitors. I'm gonna put a jumper here, and we're gonna pull, and it runs over to here. I already beeped it out before you guys. We're gonna pull this jumper out, and we're gonna inject our composite right here. So our composite will come in. I'll put the capacitor on the other side. It'll come in. We'll put the jumper, and then it should go right into pin 17. So let me get a little. Let's see if I can solder that jumper in. Okay, so let's see. I might be able just to put a solder over it. Okay, let's bridge that guy. I might try to get just a little bit of solder on that, and then we'll get a little metal. We'll use a. Okay, here we go. Ooh, ooh. I could probably bridge that. I'm not going to bridge it with solder. This is so small. If you bridge that with solder, you could burn into a trace. You could burn into a trace right next to it. So let's just bridge it with a wire from the. There we go. Ooh, come on, baby, get in the middle, right there. Oh, right there. Boom, perfect. All right, let me get my snippers. And we'll cut that. And we'll cut that guy. Boop. All right, cool. So let's, I still got my meter, or my buzzer here. So let's go, I'm gonna go here to the composite. Now we should be good to go up to 17. Let's see. I think it's one of these. Right there. Okay. So when we inject here where my red tip is, we're going to inject there. We're going to put that capacitor, remember from the data sheet, the low voltage requirement for that chip. So we'll put the capacitor over on the other side. That should have been here, just wasn't populated from the factory. Now let's check our red, blue, green, make sure they're isolated. And they are indeed isolated. Okay. Now the blinking signal has a resistor to ground, but I think that's okay. In the schematic it shows this resistor to ground. So I think that blinking line normally is pulled low until a blinking pulse is applied. So shouldn't have to do anything else with the blinking. Oh, we got red, green, blue, blank, ground. All right, let's get this jumper out, and let's be creative a little bit. We got a little bit more room here. So okay, we're gonna use. Where's my small solder wick? That's okay. So let's just let's pull that solder off, and that jumper will probably come right off. I could probably just pull the one side off for now. Ooh, it shifted on my block. So let's just, there we go. Perfect. Let me get my needle nose. All right, so you should pretty much be free. You got to be so careful, guys. You make one mistake and take your pliers and then you don't want to be doing rework and patches on this stuff. All right, and then when we flip that over, he'll pull out. So let me look at my. Let's where I pulled those resistors off. Let me solder wick and clean that up just a little. I like my stuff good. Where I added that solder and I didn't need to. Let's get him sucked back off. So let's pull him back off. Ooh. Ooh. Yeah, that looks pretty good. Let's get him just so nothing can stick to it in the future. And let's get him cleaned off here. Just takes a little bit. Oh, perfect. I can actually probably get him a little bit more. Ooh, nice. Perfect. That looks great. I'm working under my mag glass. I don't see. Oop, what's that? I got like a little. Oh, those are the little nope, that's not the resistor. That was just. Gotta be careful. That was a little solder glob. All right, good stuff. Let me. I'm gonna save those 3 little resistors. Those 3 0 ohm resistors. Gosh, they're small. All right. Well, if I ever need a 0 ohm resistor surface mount, I got 3 of them. I think that'll do it for that side. Let's flip this guy over. Let's flip that guy over. Spin him around. Okay. CN106 here. So this is where we're going to be landing, and this should be our this should be the one. Here's going to be for our composite. There's where we're going to inject our composite. We'll put a resistor up here. That's the only thing I don't have, or I could probably finish this out tonight. We'll run down to the electronic shop. That's what I love about living in Thailand. They still have electronic shops. Okay, let's RGB, blank, and ground. All right, let's get this guy set up a little different. Since we got the camera rolling, I got my beautiful camera lady on the job. She's shaking her head. She's like, that's right. So let's go ahead and since we have this up, let's go ahead and get our wire in there. So what do we need? Again, we need red, green, blue, a blank color, and a ground. Let's start from the ground. Okay, so you can do this a couple ways. You could use connectors. So like because you got to think, this has got to run when it's together to the back of the panel. You got to be able to open it and have enough wire, or open it and have a connector. Well, I'm not doing a connector. I have all kinds of wire that I'll never use, so I'm just going to use long wire. So when the chassis is in here, you got to imagine the chassis will be here. It's going to be about halfway, so it's going to land probably about here. And I'm just going to go with a nice long piece, and we'll tie it up when we put it together. So you should be able to unscrew the housing, and it'll give me enough room to solder it to my BNC connectors I use. I think that's long enough. All right. So, or maybe I will grab some connectors since I have to go back to the electronic shop. So that's black. Yep, it wouldn't be a Arcade Laboratories video if it wasn't 2 hours long, but you know, this is you know, the stuff in between a lot of people cut out, like, but it's the important stuff. There you have to be detailed with component level work and every step. So we're just going to make these the same. We're going to make these the same. What do we got? We got black, blue, get red. Get red. Yeah, it's unfortunate. If I had that capacitor, I'd fire this thing up tonight, but electronic shop will be open tomorrow. Okay. And green. I wanted, I got him tied. Yeah, this is just 22 AWG 22 gauge wire. I can buy this here in Thailand. It's great. It's the real thing. All copper. This stuff is a good conductor here. I thought about using ribbon cable. It's kind of why I did have my ribbon cable out, but I think we'll just clip on when we go onto the breadboard. And we need a blanking. I think I want to use, I wish I had a white color. Probably could use yellow. But yellow is going to be also for our video. I like to use, we're going to have to double up on another color. Blanking, I guess since blanking is going to kind of be tied to voltage, we'll use red. And just have to keep them separate. Red or blanking. That's fine. That's fine. Okay. Alright, let me get my handy dandy strippers here. So I actually like these. I didn't like them at first. A buddy of mine turned me on to this style of stripper, and I'm kind of old school and set in my ways. But these things actually work good. So it's got a little backstop. I think we'll trim later. I can go about halfway to the stop. Nah, let's go all the way to the stop. When we poke it through, it'll give us some good solder material when we solder on the back of that thing. You could probably do like 4 of these at once. I have done 4 at once. There goes my meter, always shutting off on me. Thing makes me upset. And the black. Okay, boom. All right, let me back over here. I'm gonna grab my flux. I'm gonna show you guys how I do it. All right, guys. So let's get this moved back where I can sit and you guys can see. Well, I about did a Todd Tucky and fell out of my chair. Okay, that's funny. Okay, so what I like to do, I'm gonna be putting them in that small hole. This wire fits, but what I like to do, I like to twist it, and then with some paste flux, I'll dip it, and then when I stick it through that solder, it just soaks right up in there and creates such a good joint. Yeah, I think after getting these wires in, maybe we can do the 5 volt. Maybe we can do our 5 volt line. Might as well. It don't really take too long. Okay. Yeah, probably a bit long wire, but I have it. And I'm never going to use it all. Okay, what do we got first? We have ground. Let's do ground first. Ground is in the back. So basically I just take it, dink, dink, dink. I dip it and find the corresponding connector hole. Red, green, blue, blank, ground. Red, green, blue, blank, ground. And then, yeah, watch on this side. Can you zoom? Hang on, let me move the light so you guys can see. I can kind of see the camera now. Yeah, I want you guys to be able to see. And then you can zoom up right here. Yeah. There you go. Yeah, there you go. Red, blue, green, blank, ground. So when we melt this, that guy should push right through. Oh, maybe if I can count right. Am I on the right one? Red, green, blue, blank, ground. There we go. I was not on the right one. All right, so we're poked through. Hope I didn't short that out. We can go ahead and clean that up later. What? All right. And let me get my. This is what I like about my blocks. I can really sandwich stuff and get my boards where I need them. All right, and then just give it some solder. Yeah, those pads are nice and big. And we'll come back through, depending on how big. And then watch how nice that solder, whoop. See how nice that solder sucks to the sticks around that. Okay, blinking, we want red. Blinking, we want red. Yeah, I just needed one more color, right? And I could have, like a white would have been good for blinking, but at least how I'll remember it. I'm like, yeah, blinking's got to go to 5 volts. It's hot, so whoop, like that. There's not enough solder on it to resolder it like that. And you want, from the other side, you want your plastic nice and flush. You don't want on the part side. I don't want any bare conductor showing on the part side. Yeah, there we go. Perfect. Okay, so that was blanking. Now we have blue. Now we have blue. That's not it. I'm losing my mind and my wires. Yes, oh, right here. Blue. Okay. They were mixed in with the the rat's nest of wires over here. Okay, so we dip it in the flux and get it started up in there. Oh, I already pulled the solder off on that guy, apparently. And let's get him soldered. Ooh. Stay in there for a minute, guy. Oh, pulled it out. Oh, this one. Okay, re-dip it, get some flux on there. I really like using flux on stranded wire. It just really absorbs that solder when you do that. I'll get in there. They get frayed on me a little. There it goes. All right. Let's get some solder on. Yeah. I'll make sure. Line him up. Ooh. Like that. Okay. What's next? I think green. Green. Okay. Green. Guess it wouldn't be a lab if it wasn't messy. Okay, green. Ding, ding, ding. And that's one thing I really enjoy about this hobby is I actually enjoy the soldering. I like doing high quality work. You know, I've seen a lot of stuff come across my bench that people have worked on before that just, you know, they kind of made the problem. But I enjoy doing quality work. I enjoy saving the electronics. Ooh, I got a nice blob over on the pad next to it, but that's okay. If I can get it off, there we go. Ooh. Oh, I'm going to have to add some more solder to him. Actually melted the plastic on the other side. Well, at least I know it won't short out. Oh, there. Yep, see, you got to be really careful. Look at that solder ball. That could cause a whole thing. Oh, come on. Oh, come on. I need a third hand. I need a third hand, guys. Anybody give me a hand? There we go. Stay right there. Oh. There. Stay right there, you dog. You just gotta be patient, you guys. It's like when you're doing stuff, don't get in a hurry or you will. We'll come back and yeah, I melted the wire on the other, just the insulation. And red again. This is actually the color red, not the voltage red. Not the voltage red. Okay, dip them, ding, 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 and stick him in the hole. There we go, melt now. Why? Oh, I missed it. I missed it. I missed the hole. There we go. Here we go. Ooh, there. Good. I'll give myself some support here. Sweet. Okay. So check out the other side right here. Right there. There we go. Yeah, no bare copper. You don't want, I see a little, I think I see just a little right there on the blanking, but you want that nice and tight so nothing shorts out on itself. Yeah, these are pretty long, but that's okay. We have the wire to spare. Okay, can't do anything with the composite, so let's go ahead and grab our let's grab our 5 volts. Let's grab our 5 volts and I'll show you guys where of the box. Okay, and this is from the schematics right here. I don't know if you can you zoom in? IC002 as a regulator, pin 5. 1, 2, 3, 4, 5. Pin 5, that guy right there. We're going to grab 5 volts from him, and then we're going to build a little voltage, voltage divider, and take 2.5 volts from him. So we need another red. Let's see, I made that blanking one red. I think I'm gonna have to make it red. I'm just gonna have to be really careful. I'm gonna make it red. That's okay. You can use any color you want, just make sure, yeah, I think I'm just gonna make him nice and long like the other ones for now. Okay, where my snippers go? Right here. Snippers, strippers, snippers and tripper. Snippers and strippers. Sounds like a fun night out. So this time I went ahead, I made a lot shorter of a, of a peel back. Now this guy, let's pin 5, let's add, before we even, what I'm gonna do, I'm gonna tin, I don't know here, can you, right here, I'm gonna show you guys how I tin. I load up my hoof and come down, I dipped it in a flux, and look at that, bam, instantly tinned. That's great. So now this pin 5, let's go ahead and let's add some solder to him. Whoop. Just like that. And then, man, I kind of want to lay him down. But he needs to go. He needs to point like this direction if I lay him down. Yeah, let's just stand him up and I'll bend him. So now that your wire's tinned and we have fresh solder there, very easy solder joint. Ooh. Oh, I think I just shorted that. I just shorted pin 4 and 5 together. Oops. No big deal. I don't know if I can get him pulled back over. There it goes. Okay, I got him freed up. Okay, be careful this time. I was gonna solder wick it, but no need. Okay, let me put him on this side and stay away from pin 4. That's it. That's it. You can zoom in nice and close and check that out. And then I do have, since that is 5 volts, I do have some shrink tubing. Find the right size. Yeah, I do have some. We're going to put a piece of heat shrink on it. Got red. That's the smaller one. Okay, that will work. Just to make sure, because that is 5 volts, we don't want anything shorting on it. Okay. And we'll run him down. Yeah, next thing we'll do, we'll get tomorrow. So what I like to do, I just use my solder gun, like either it just depends on where I am. Actually, before I do that, let me look and make sure that's not shorted. Okay, it's not shorted. Okay. Put a little downward pressure on it. I just like to use my gun. I like to use my heat gun, but it broke. I don't have it right now. Yeah, so I just use my solder tip not to touch the board or burn my tip. Yeah, I think that's probably okay. That's fine. I didn't get the very bottom, maybe on this side, because I don't want to desolder anything. That's fine. That's it like that. So now that cannot be shorted, and then we're just gonna end up bending it. That's what's nice. Like on this chassis frame, there's no ribbing. Like the Hitachi had ribbing, and all my jumpers you had to be careful, but this guy is gonna be okay. And then there's many holes to select. Okay, let's find a place to bring him in. So this is going to be for the 5 volts. He's going to go towards the back of the TV. So really, like this, that might be is that a hole? No. Oh, right there. That's a nice hole. Oh, I can't find it. Oh, right there. Oh, nope, not too small. Just pull him through. I like that. And that'll be right near the back of the TV. Okay. If you want, we'll see if I need to get the glue gun out for any of this. I might get the glue gun out. I don't like wires and stuff hanging unsecured. Oh yeah, like that, just like that. Bend it like that. Let's put a little bend right there. Yeah. Yeah, I'll get the hot glue gun out later and we'll tack him down. Something like that. We're in the zone. Okay guys, I think let's flip it over, spin it around, and see what we got. Okay. Yeah, this is nice. Okay, so we have all of our wires. Excessively long, but I don't feel like really dealing with the connector on this guy. Maybe we will. It's not done yet. So we have him. We have our ground, blanking, blue, green, red, and then we have our 5 volts that will toggle our blanking, and right here will go our 0.1 capacitor. Now what that's going to do is going to take that source signal, like from your Neo Geo or your DVD player or whatever. It's going to knock it down to be within a safe range of this guy. And then same thing, we'll have to add our resistors, our 75 ohm resistors onto our RGB, but we'll do that at the jacks on the back. And we're actually, I think that's why we're going to breadboard it. I want to breadboard these first and get the picture dialed in. All right, guys, so I think that's it. We can wrap it up, and we'll come back when, I get that other resistor and get this kind of put together a little bit and ready to fire up. But that's it for the wire installation. It's very detailed, step-by-step, kind of some of the tools and techniques that you can use to do that. Okay, we'll be back. Geez, how long was that, honey? 35 minutes?
Yep.
Real? Good. No. Holy shit, 50 minutes. Ooh, thank you. Okay, hey, we're getting back. We cut back. So, as you can see, we have RGB. We have RGB coming pretty nice and clear on the Sony Trinitron. So, right now, I'm using the Neo Geo, and like I said earlier in the video, we're getting ready to analyze the RGB, the color signals, and the sync signals. But before we do that, yeah, it looks pretty good, right? So, but before we do that, I want to go back and edit some of the things I was saying in the part 1 of the video. So basically, I was not able to get, I could not use the pin 17, the external, composite, excuse me, rusty today. The composite input cannot use just because it's not connected. There's no way for this chip, the microprocessor, to switch to this input to allow the sync in to the deflection area of the monitor. So remember, this is a RF only input, old antenna RF input. So, but what I was able to do, kind of looking at the schematics. So here we have an IF video output. So basically what I did, I come in and checking out the schematics, I went ahead and cut that. So the IF input is actually coming in on pin 13. The component, composite video input and internal. So if you follow this video, this IF out, it goes up through some filters, through some circuitry, and loops back in. So basically, I cut the out actually up here. I'll show you. Follow this guy up and around. Comes in here because we wanted to use some of the components to get the voltage kind of where we needed it. I'm injecting somewhere up in this area. I think about here. And then coming back 13, it makes its way back, comes into 13, and luckily we got sync. So that's the only adjustment I made since that last video. Being an RF only TV is a little bit tricky. Okay, so I have a little breadboard set up. So basically what I have, I have our sync signal coming in, our RGB, and our blanking line. Just a little breakout box so we can kind of look at some of the voltages and show you guys exactly what we need here, or what we're looking for. So I think the first thing I will show you is the line dividers. Let's look at the blanking. So the blanking requires like 3 volts per the chip signals, 3 volts max. So we were able to use a 5 volt, and let's measure. So let's zoom in. You can't hardly even see that. So for the blanking, made a voltage divider. So have the 5 volts coming into the switch with I think these are like 150 ohm resistors. 2 resistors, the same value, other end going to ground, and this is our 2.5 foot line. So let's zoom out and let's measure on that, and I'll show you guys. Okay, let's go let's go on the ground. The blue is the ground. All right, 5 volts. So that's our 5 volts that we hijacked, and then the output blanking line. Oh, it's like 2 volts. I'm not sure what the deal is. So let's go ahead and hit the switch here, and you can see we turned off our RGB outputs, and we have 0 voltage. So we'll turn that guy back on. We have 2 volts, which is under the 3 volts that we need. So I've only done 2 RGB mods, and I can say the input voltage for the blanking has been different on each set. So kind of keep that in mind. Okay, so let's look at the color signals coming in. So we are looking for I just made some notes here. RGB input. I think we are actually want to look at the outputs. So basically we want to have these under 2 volts. It says RGB inputs 700 to 800 millivolts, but I do believe that's the inputs, and we're dealing with the output. So these are going out to the neck board. Okay, so anyway, let's measure on those and at least show you what some color signals look like on the scope. And okay, and another thing we're going to do, let's go ahead and I'm going to take this thing out of the tripod. I think that's fine. Or we're going to be wasting a lot of time. Okay, so right now I have a 75 ohm resistor as the load. Yeah, the 75 ohm termination from ground for each one. So what we're going to do, we're going to take the measurements, we're going to look at them like that. Then I have some 100 ohm variable resistors, trim pots, set up to see if we can't dial in the picture better than the standard ohmage. Okay, so let's probe there on the blue. So we're getting volts peak to peak under 2 volts. That's probably a pretty good. That's probably a pretty good area, and you can see our picture is actually pretty good. So your voltage is going to basically adjust the brightness of your picture. So I mean, it's just cycling through different screens, so your voltage is going to be different. And let's go red. And red looks pretty good. Okay, so we've got volt peak to peak. Okay, so just in case, we're on 1 volt division and 200 microseconds. And yeah, 1.5, 1.6. You could look at either one of them. The max or the volts peak to peak. They should be pretty close, but your max is going to probably show you. It's going to show you your spikes, your high spikes. And I kind of like to see both. And maybe the peak to peak seems to be a little higher. 1.5, 1.6. Now back to the blue. 1.5, 1.6. Let's just take that down. 1.5 to 1.6. Okay. That's actually producing a really good picture, but maybe we can get it better. So if you have time and you kind of want to know, like, why you need the 75 ohm resistors or resistors. They don't have to be 75 ohm. They can be a different value, like on the Hitachi. They were okay. So I'm going to swap over. Okay, so disclaimer: I have the trim pots all set at 50 ohm right now. So let's switch all these over to the trim pots. And we got 50 ohms here. All right. Gonna be a super long video, but so let's look at the picture here, and let's look at our voltage now. Actually, at 50 ohms, blue. And once we get the picture, I mean, that doesn't look too bad. White is white. Get my camera to. Oh, just yep, there it goes. Yeah, the blue is blue. That looks pretty good. But they're all going to be adjusted the same. It is a little dim, like the red, the blue, and the green. I don't know. That looks pretty good. Okay, 50 ohms. Looks like we're maxing out. I see like 1.2 volts. Just go green. .2, 1.3. So we're definitely down a little bit lower. And then red, 1.4. So we're like 1.2. I'm just going to call it 1.2 to 1.4 at 50 ohms, and this is at 75 ohms. Okay, so let's do a little bit of adjustment. And I already know from this counterclockwise is going to raise up. See, I've got the input on one side of this wiper. I got one leg up, so we've got basically an input and an output. They're all the same, and I know counterclockwise is up and clockwise is down in this configuration. So let's let me get the let's clip onto one of these guys while we're doing this. And we can adjust by voltage. We can't take our resistance while we're powered on, but let's. Ooh, if I can clip onto that without pulling that thing out, that'd be great. Okay. So there's our blue. And let's go up with him. 1.3, and we can kind of watch here. Okay, so 1.5, 1.6 is going to be, you can see it moving up on the scale. Now when we get a picture, there's 1.5, 1.68. That's probably around 75 ohms. Let's go up a little. Let's take him peak to peak. Let's go 150 to 160. Just a little bit, man. I don't know, that looks pretty freaking good. We're just going to do this by voltage. Okay, well, I see 190, 170, 160 to 190. Let's see. I'm going volts peak to peak. I'm not really paying enough. All right, let me write that down. Just kind of have to watch it for a while and try to get a good average. 160 to 180, 1.6 to 1.8. Okay, let's adjust these other ones. All right, so the blue's gonna, right now if you look at it, the blue's gonna be a little bit strong, but that's okay. We're gonna match the rest of them. All right, so let's take him up. Now 1.3. You can kind of see it going up on the scale. Where we say 1.6 to 1.8. I think that's about it right there. You can kind of tell on the throw on your pots. They should be pretty close. The slot orientation. 1.6, 1.8. That's probably 1.84. That's kind of. We could probably go down just a fuzz. 1.6. It's a little bit more stable than the blue. All right, I saw 1.7, 1.6, 1.7. Okay, we're gonna call him good. And then let's get over here, wait on the red. Oh, this pot has been giving me problems since I put it in there. It's trim pot. Come on. Okay, I gotta put you guys in the tripod. Yeah, making the world's most awfulest video here. That's okay, maybe somebody will learn. Yeah, basically just pulled my pot out. My trim pot, that is. Now we gotta get clipped on here without pulling him out. There we go. There we go. Okay. So he was actually a little bit lower from the 1.5, 1.6. Could be my. All right. So let's turn him up. Try to match the voltage to the other guy. So we're gonna go for like average 1.6 to 1.8 volts. Let's see, 1.5. Let's go up a little bit more. You can kind of see it creeping up the scale a little. There we go. 1.6. Yeah, 1.6, 1.8. Okay, let's see what that looks like. Let's watch this for a minute. Looks pretty good. So basically we've upped the voltage, which should have brightened up the picture a little bit. I don't know if that actually started a game or what. I think it did, maybe. But yeah, the colors look good. Let me reset it and let me reboot it. You can watch it from the. Yeah, the green looks good. What I look for is the white and the black. That looks pretty good. The blue is pretty bright. I think that's actually better. I actually think that's better than the yeah, see the red, the blue. I think it's actually better than the 75 ohm. It's probably pretty close. I know it's hard to tell in the video, but some TVs, why I'm showing this, some sets you will have a bigger difference. If you play around with your resistors, like with the trim pot like I'm doing, and you find that you're way off, by all means, you don't have to use a 75 ohm for your termination. Yeah, that red looks good. That looks nice. Okay, so let's see let's see the value. Let's see what we ended up with on those. So let's we're gonna power down. We're gonna power that down. Now let's measure the resistance of. Let's measure the resistance of that. Where our settings are. Let's get him off of there. Any guesses? I'm guessing. I don't know, 80 ohms maybe. So basically, we're just gonna come in on our trim pots and measure leg to leg. And if you guys don't know exactly what trim pot is, look up a data sheet. Yeah, 86 ohms. 86 ohms. So 10 ohms more than the 75, and I believe has a little bit of difference. Let's see how close we were on adjusting them out on voltage. Okay, green was 95, so we're like 20 ohms over there. And let's see how we did on red. Oh, come on, red. Come on, red, you're my boy. 86 ohms. So we had green just by going from, the O-scope, dialing it in just from an average voltage. Yeah, it was more or less pretty close. So I don't know, 80, 85, I don't know, 80, 85 ohms. Yeah, we could put 85 ohm ones in here. So let's get this back disconnected and powered on, and next we'll move on to the sync signal, because there are a couple things I want to show you about sync signal and knowing your sync signal, because knowing your sync is just good to know, like for board repair and other troubleshooting. There we go. All right, come on, Red. I'm being a pain in my butt. Come on, Red. There we go. I think we can leave that in there for now. Let's power back on. Okay. Thought I saw a little 3 burn up in there. I had to be honest, I think that Hitachi, the Hitachi looks better than the Sony Trinitron. Everybody's like, Sony Trinitron. I tell you what, that Hitachi over there, I think looks better. This looks great, but that one over there, man. Okay, so sync signal. Let me zoom you in. I'll show you what we got going on if you can see through the mess here. All right. So what we got going on, we have our sync coming in, and I do have a termination. I got a 75 ohm termination. Look, I'm just looking to bring down the voltage. This is not necessary, but I threw a capacitor in here for decoupling. When I was troubleshooting the problem I was having with my sync before I fed it into the other pin, I had a wavy screen from this guy. So when I isolated him out of the tuner, between the tuner and the jungle chip IF, there's a sawtooth generator. It was creating interference, and it was messing up my sync. So he had to come out, and then the sync cleared up. Okay, let's get the probe going. Okay, so let's look at what I want to really show is, let's just go to the scope. I'm just gonna pull these out, and we're gonna look at some of this stuff separately. I'm gonna isolate him. All right. So there is our sync signal coming from the Neo Geo. I just offset it down so we can get it all on the screen. And look, so we've got almost, let's call it 5 volts, 4.6. It's kind of bouncing around with some noise and some ringing. 5 volt signal, and you can see the frequency. It's our 15.6 kilohertz frequency. And that is typical of a PCB, an arcade PCB sync signal. And you don't even need a monitor when you're doing board repair. If you should be able, just like how we did here, if you probe around on the edge connector, you probe right here on the edge connector, you should be able to see your colors. Boom, boom, boom. You don't even really need a monitor. Unless you really kind of want to see. But if you're troubleshooting something that just landed on your bench, it's a good way to tell, just by knowing what your signals are supposed to look like. Okay, so back to the sync signal. And looking at the data sheet for that jungle chip, it was saying 1 volt to 1.4 volts is a good voltage, optimal voltage for that. Okay, so I put it back in circuit. I connected it back in circuit. We were just measuring here. So I've got 75 ohm resistor here, and so basically, let's look at our signal. Let's look at our signal with a 75 ohm termination load and decoupled. The decoupler is not going to do anything for the voltage. So yeah, sitting at 1.4, we're sitting at the top end of the recommended. So let's do this for just you know, I'm kind of beginners too, but nobody ever shows this stuff in the RGB videos. So again, right now we're back up to the 5 volts, right? And then your resistor is gonna pull it down. It's not, you're kind of getting to like a half of a voltage divider kind of deal. Oh. So let's measure. Now I put this back so we have our signal to ground through 75 ohm, and that puts us pretty much on the money. And then, okay, so that's not coupled. It's actually a bit higher. Well, we're not loaded down either. I've got the sync disconnected. We're not actually loaded down either. So I'm going to be a little bit higher. Now I'm probably going to take this decoupler out. I was just using that for trying to troubleshoot that crappy sync signal before I isolated the tuner. 1.7, let's see, I'm going just volts peak to peak. 1.8, 1.7, so it's a little bit high. Let's look at the other side of that decoupler. It actually lowers it, average what, 10 millivolts, 15 millivolts, or 100 millivolts, I mean. Yeah. Okay, so I'm going to leave that connected up here. Now let's get the sync circuit finished back up and see if the load pulls it down at all. So what we got here? We got 1.7, 1.5, 1.7. Here we go. Boom. Now we got our sync. Yeah, it changed. You can see the load pulled. Now it's pulling amps and it's pulling voltage. And now we're down into the safe zone of the recommended signal for the jungle chip. All right, guys, that's I hope that was informative for somebody. I think it was kind of fun. I kind of liked making a breakout so we can look at the signals together. So basically, I mean, the takeaway, you want around 2 volts for your signal. Actually, let's disconnect a couple of these guys. Let's disconnect Blue. Come here, Blue, you're my boy. Oh, my boy. All right. So Blue just straight off the board. Let's see what. I mean, you're looking. See how it's raw dog? 4 volts. 4 volts without a load, without an impedance load, and that's exactly why you need them. That's when they're like 50 ohm, 75 ohm. You need to get that voltage down so your processor can process it and you don't damage the components. So I think around on the neck tube, I really think you should be around 2 volts. So we put Blue back. Blue's back in circuit. There we go. 1.4-ish volts. And, okay, I saved this till last, guys. I don't know why I saved this till last, but check this out. This is kind of cool. So since this is not a normal mod in terms of sync and composite, having an external video in, check it out. Boom. I still have all my OSD. So I know we just fine-tuned our picture, right? But check it out. I still have picture control, color control, bright control, sharpness control, and volume. I thought I would try to do, I thought I might try to hijack the sound so I can do my sound, but I don't know about that yet. So we just dialed it in with the resistors. On this particular mod, we're going to be able to go in and adjust it more. The color. I mean, I already played with it. It actually works. It actually works. We can go down. It's slight, but well, maybe it don't work. I think it does. Let's see. Bright. Let's do bright. Oh yeah, it works. Color just wasn't doing a whole much. But before I made a video, I set these all about halfway, just like I would do with anything with a potentiometer. And set it midway, adjust the hardware, and then you can come back with the software and fine tune it. Okay, I think that's long enough. The next step, I'm either going to play with the sound, and it's time to get the case modified. We got to get the case done. This is going to be pretty easy. Check this out. So this is where the original, not the original. If it was a different model, this is where your BNC or your RCAs, excuse me. But check it out on the inside. They've got the holes already, at least 4 of them. So that's a red, green, blue sink all day. And they're kind of molded plastic. So that should be really easy to use as a template with the step drill. Should be able to drill through there. If I can get the sound or not, I may throw an audio in a pot back here, just so when somebody can use this down the road and as a full-fledged sound and monitor system. Okay, we're gonna end there. I hope you guys like this. So now it's time to break this down, get everything wired up. More permanent. Okay, thanks guys. We'll be back in a second. Okay, so hey, I'm just gonna go ahead and continue to work on getting my BNC connectors, or not BNC, RCA connectors. And I wanted to show you what I'm using here. So I bought these at the local shop. Can you see those okay? Yeah, so basically, yeah, these are great. I used them on the Hitachi. So we got to drill the hole. They have a ground tang. And yeah, these are really nice. Gold plated, somewhat cheap here. So let's go ahead and I think what I'm going to try to do, I think I'm just going to use that, oh, can you get in here? Actually, we're going to be coming out right here. So, and look, it's like rubber. I already kind of poked on it. Look, I'm pushing on the inside, and you can see it. I'm centered up. Whoop, like that. Yeah, that hard plastic is gonna be my guide. Okay, this one's kind of close to the edge. Yeah. All right, and we're gonna finish it from the other side. All right, now we're gonna come back in here, back over here. I don't know, it's kind of dark. Yeah. Let's go ahead and, ooh, that's, oh, look at that. You broke that really nice. Ah, you broke that really nice. Spoke too soon. All right. All right. These are pretty good, actually. Let me get one started. Let's get a couple started. Yeah, they're kind of. Since I'm not using a connector, I have my wire roll on, kind of like I showed in my one video. But I have to reach in here and solder these, but it's okay. And then I don't know if you can show these, but this one has a knurled edge on it, a milled edge for your ground ring. So I like to put that guy in first. I'm just going to reach in. I'm going to start him. I'm going to flip this around. Maybe you can show the inside too. And then I like there's like that little cup. I have that facing down, so when I get my hand in there and solder, it just solders really well. This guy, that's your ground. We need these. The other washer. And the nut. Ooh. I hope there's enough room. Yeah. Yeah, it's going to be close. I don't know if there's going to be enough room now that I did that. Yeah, it sucks. See right there? Let's get another one. Maybe not enough room. I don't think there's going to be enough room, but I have plan B. Let's get this guy. Yeah, I just decided to film the whole thing. I watched a lot of RGB videos and they're great, and there's a lot of work behind the scenes. I just kind of wanted to show you what it really looks like. Actually, let's see if that guy will fit on there. Oh, it's gonna work. Nice. Okay, now I have to get these, get that ground in the right position. Let's put him over like this. Come on, baby, get on there. Get that roll. Yep, the joys of electronics. There we go. Yeah, I can. That's not too bad. I can get in there and solder on those grounds and everything. It's not a big deal. It's not that tight. Cool. Okay, two more. Okay, get the guys ready. I didn't think there was going to be enough room for the washers, but there is. It's good. Get the right one on there first. Yeah, it is tight, but I ain't gonna say it's not. It is tight. It's tight, but we're going. It's good. Okay, got the ground. Get the retainer nut. Down where we'll get in here and we'll tighten these in a minute. That's great. They're all going to fit. Barely, but they are gonna fit. That's good. Okay, good deal. Okay, we're going to cut there. Basically just going to tighten those down and get these guys into place for soldering and get this stuff soldered. So we got to solder. Actually, they're going to go to the electronic shop. I just did my calculation. Instead of, I think I'm either going to get 82 ohm or 91 ohm resistors. You know, after we did our experiment here, I can up the resistance, get a little bit brighter of a picture without washout. So I'm going to go for it. So I think we're going to leave that here for now. But yeah, this is kind of what it's going to look like. So it's easy, like, yeah, if you use a cable, you can solder most of that and then put them in. It just depends on how you want to do it. I don't mind having one big long cable and just be able to pull it all out. And I can get in there and solder. Not a big deal. But yeah, it's going to look good. It's going to look pretty awesome. So, okay, we'll be back. Okay, so we're back with the final assembly video before we clamshell this thing back together. And the picture is just beautiful. So, since this thing will never see the light of day again, I thought I would go ahead and show you the final work, what happened. So we're live right now. So I went ahead and I put an audio amp in. I tried to find the RF sound and hijack and use that sound amp and the onboard OSD since we still have that control, but I couldn't find it. I probed around the SIF, the sound infrared sounds, traced back that, and I just was running out of time. So I went down to the local video store or electronics shop. Yeah, $3 5-watt amp. That's fine. And it had a trimmer pot for the right side. And I just went ahead and removed it, ran it down to a, what is that? It's a 10K pot. I have audio in. We have our blinking switch. And we have our red, green, blue sync. And remember from the testing that we did, I went ahead and used 90. What are they? They're 90. They buzzed out at 90 ohm. I think they're supposed to be like 89 ohm. And I just went ahead and used 90 ohm. And I did go ahead and do the sync as well. I did go ahead and put a 75 ohm on the sync, just so everything's at the right impedance. So I got a couple cables here. So that amp actually runs off 9 volt, and there's all kinds of 9 volt on this chassis. So I just tagged 9 volts right there, and I did give it a separate ground. I thought maybe some of the passive components would decouple that soundboard, that audio amp, from the video amp. I was a little scared to use the same ground there. Yeah, I didn't want any interference in that picture because it looks awesome. So since this was a complete video, I'm going to go ahead and pass the camera off, and we're going to go ahead and do a final wrap on this. So let's go ahead. We'll shut down. Now remember, yeah, we did not use the 75 ohm resistors, but we know from our testing that we're not even overdriving. We're not even overdriving the voltages. So, and I really hope this guy fits, because I noticed when I was soldering this all in on the back here, that right where this board goes, it's going to be so close to the bottom of this board. So let's go ahead and let's line her up. No, yeah, let's see, the power cord is going to go under here, and then there's like another power, or another clip for the power cord. And I got some cable ties here, and we're just going to go ahead. Yeah, I mean, you can use cables and connectors, but I did not. We're just going to make a loop. We're going to make a loop like so. Can you see that? Yeah, I'm just going to make a loop like this. I'm going to cable tie it and just lay it over. And no connector needed. I mean, don't get me wrong. If I was at home and I had my crimpers, my bins full of all of my Molex connectors and pins, and I probably would have built a connector for this. But being here, and I have plenty of wire, like I keep saying. Need my snippers. Where did I put my snippers? Oh, right here. Okay. Let's snip that. Actually, I think I'm actually going to put one more cable tie in here. See how this guy is kind of coming over? I think I'm going to put one on this loop. Right here. Yeah, it's a lot of cable, but you know what? I don't care. It's a nice... You can pull that thing apart and troubleshoot it. And that's what I like about using solid state. No connectors. No connectors can go bad. As long as you don't... oh, come on. As long as you don't short anything out or... Come on, baby. Man, my hands are all burned up. I burnt the crap out of my fingers soldering all that stuff back there, though. That was the only bad part. Okay. Let's finish the connection. I'll kind of keep an eye on the wire. I think we're gonna fit here. I think he's gonna fit. Ooh. That's bottoming out. I'm going to go ahead and remove the BNCs. Oh, I didn't even show you guys the back yet. Let's see if this other side. We might be hitting that board. You look here. Whoop, got a solid line. I think it's hitting that board. I think it's hitting those BNCs in the back. That stinks. Oh, there it goes. I had to give it some love. Okay. Cool. Let me get my screws. And let's get this guy put back together. And hopefully I didn't mess up those RCA jacks too bad. Yeah, I should have been ready. Nothing like watching my videos, waiting for me to find my tools. Let's just get some screws started. And then we'll tighten everything down kind of together. Get some screws in there to start putting this thing together. I'm just going to put them in snug. You guys know how I feel about proper torque and snugging things, and we're not going to crimp down on those yet. And, you know, little Sony Trinitron, my first one. I was gonna wrap this video up by saying I think that Hitachi was a better pitcher, but honestly, when I put the solid state or got rid of those trim pots and put in those 90 ohm resistors, oh, the pitcher is very nice now. Yeah. Okay. Let's get this guy. Let's get this one pulled together on this side. Okay. I'm just gonna pull this. Pull that guy in. Come on, baby. Oop. All right. Now this is the side. Yeah, that board is hitting like right down in here, right below those guys. So hopefully, ooh yeah, look at that. Oh man, I think we're just gonna put them screws in and not worry about it. That's kind of big though, isn't it? Ooh. Nothing I can do about it at this point. Oh, I hate that. That's not perfect, damn it. But I think we're gonna put these in and see how well she'll tighten down, and hopefully I didn't mess up any of that ground wire back there. Yeah, let me see if I can. That dude didn't go in. Ooh. Make sure it's not something else getting in the way. I think it's okay, actually. Gonna be okay. Let's see how well it pulls in. There's still a gap there. Right, well, not too bad. There's a little bit of a gap there. All right, let's pull this thing down. Then we're gonna plug it in, do a final wrap up, and I can finally move on. So you notice the other box? Now we got repairs rolling in. That's next on the list. Got a friend of mine up in Chiang Mai. He's got a small home arcade, and he sent me some Neo Geo stuff and what's that other one? A Raiden, a Street Fight, Raiden Fighters. Not an easy board, but yeah, I don't know. This side's got a little bit of a gap too. It might not even be all part of that. Yeah, nice little Sony. I wish the thing wouldn't have fallen off here. The placard. That's a little bit of a gap. Okay, so let's go to the back here. So we have, I gotta put labels here. RGB sync. Here's the audio. Here's potentiometer. And here's your blank switch on and off. Yeah, fantastic. Let me flip this guy up and see what's happening here. I thought there was another piece. Yeah, I think he goes in here somewhere. We'll get, oh, he goes, oh, I see where he goes. He does, he wraps up around like that, and he goes like this. Let's see, how did that guy go in? I know I didn't break it. Oh, okay. There. Yeah, like that. There we go. Strain relief. I love it. And so yeah, and again, no composite video. We modded a RF only TV. That's pretty cool. All right, so let's spin that guy around. Let's plug them in. Let's turn them on. And I can try to remember my cable colors here on the back. Okay, what do I do? Okay, I start with this cable. I go red, green. The single red is the blue. Sync. And the single white is the audio. So cool. I hear sounds. Oh, blinking. Boop. There we go. Bam. Look at the color on that thing. Oh, let me have that. Ah, yes. Yes, look at that. And we still have our OSD control. We still have OSD control, so we can tweak our picture from there. Yep, I tried to hijack that volume, but it wasn't happening. Was not happening. Well, guys, that's gonna wrap it up. Extremely long video, a bit of two video. Look, I'm sitting here sweating. It's all hot in Thailand. But I needed to get that done because we got other stuff to do. But I'm pretty happy with that. Until I put in those resistors that we measured, that image was not that nice. And the Sony Trinitron, how they brag them up, I tell you what, that Hitachi over there is every bit as bright and clear as this thing. So hey, I hope that helps. Extremely long video. See, my fingers are all burnt. Time to put this one on the shelf. Okay, thanks guys. See ya. One last quickie. Man, look at that picture. It is really amazing. See if I can get that out of there, that refresh line. Yeah. And then the back turned out really well too. I'll show you the back one more time. The back looks great. So standard only had the RF. We added RGB sync, audio. See that blinking? That it's like an inset, little molded in the plastic, and so the blinking switch barely sticks out. It's like low profile. It's really cool. And then yeah, the volume for the new audio system. Oh, talk to the hand. Oh yeah, yeah. I'm gonna get rid of those. Yeah.